Strange objects found at the galactic center are like nothing else in the Milky Way. There's something really weird in the center of our Milky Way galaxy. The vicinity of the supermassive black hole is a pretty weird place to start with, but in 2020 astronomers found 6 objects orbiting Sagittarius A that are unlike anything in the galaxy. They are so peculiar that they have been assigned a brand new class, what astronomers are calling G objects. The original 2 objects, named G1 and G2, first caught the eye of astronomers nearly 2 decades ago, with their orbits and odd natures gradually pieced together over subsequent years. They seem to be giant gas clouds, 100 astronomical units across, stretching out longer than they got close to the black hole with gas and dust emission spectra. But G1 and G2 were not behaving like gas clouds. These objects look like gas but behave like stars. Physicist and astronomer Andrea Ghez of University of California, Los Angeles explained back in 2020. Ghez and her colleagues had been studying the Galactic Center for over 20 years. Based on that data, the team of astronomers led by UCLA astronomer Anna Ciurlo identified 4 more of these objects, G3, G4, G5, and G6. They're on wildly different orbits from G1 and G2. Altogether, the G objects have orbital periods that range from 170 years to 1,600 years. It's unclear exactly what they are, but G2's intact emergence from periapsis in 2014, that is, the closest point in its orbit to the black hole, was, Getz believes, a big clue. At the time of closest approach, G2 had a really strange signature, she said. We had seen it before, but it did not look too peculiar until it got close to the black hole and became elongated, and much of its gas was torn apart. It went from being a pretty innocuous object when it was far from the black hole to one that was really stretched out and distorted at its closest approach and lost its outer shell, and now it's getting more compact again, she said. Previously, it had been thought that G2 was a cloud of hydrogen gas, which was going to get torn apart and slurped up by Sagittarius A, producing some supermassive black hole accretion fireworks. The fact that nothing happened was later referred to as a cosmic fizzle. The astronomers believe that the answer lies in the massive binary stars. Most of the time, these twin stars, locked in a mutual orbit, hang out just doing their buddy star thing, but sometimes, just like colliding binary black holes, they can smoosh into each other, forming one big star. When this happens, they produce a vast cloud of dust and gas that surrounds a new star for about 1 million years after the collision. Something must have kept G2 compact and enabled to survive its encounter with the black hole, Ciurlo said. This is evidence for a stellar object inside G2. So what are the other 5? Well, they could be binary star mergers too. Most of the stars in the galactic center are very massive, and most of them are binaries, and the extreme gravitational force at play around Sagittarius A would be enough to destabilize their binary orbits with relative frequencies. Getz says mergers of stars may be happening in the universe more often than we thought, and likely are quite common. Black holes may be driving binary stars to merge. It's possible that many of the stars we've been watching and not understanding may be the end product of mergers that are calm now. We are learning how galaxies and black holes evolve. The way binary stars interact with each other and with black holes is very different from how single stars interact with other stars, single stars, and with the black hole. It does seem like the G objects have a lot in common, whatever they are, and explaining the data set can only provide more information to tease out the puzzle. There is, however, still a lot to figure out, like some mysterious fireworks spotting flared out of Sagittarius A that's also been spotted. Was that a delayed reaction from G2 periapsis, Or is the cosmic fizzle not so fizzle after all? We might just have to keep watching this weird little supermassive black hole corner of space to see what happens next. The research was published in Nature magazine. Earlier version of this article published in 2020. And this is on Science Alert by Michelle Starr. Please leave your comments. Thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.